Right, so we continue with 2.5 from the November 2020 exam. So differentiate the following function in terms of x, okay, with respect to x. So what do we do? First, check each term. Is each term in standard form? Does it look like one of the formulas from your table of derivatives? So let's check term 2. Term 2 is fine. Okay, this is k sine f of x. That's what we're dealing with there. So your term 2 is k sine f of x. Term 3 is just a constant. K ln of pi. Pi is a number. So natural log of a number is still a number. So we regarded that term 3 as a constant. Term 4 is in the form k times a to the power f of x. And term 1 is the only problem here. We need to rearrange term 1. So if you rearrange term 1, let's see what happens. You take 3 to the top, and if once you take 3 to the top, the sign of the exponent will change, so that will become 5x. Here, is there anything more to do? No, this is half multiplied by sine 2x ln of pi is a number. This is just 5 times 2 to the power x. So that is all in standard form. Okay. You need to make sure every single term must be in standard form. So now, your table of derivatives, I told you memorize this here. Okay, it's a foundation for your calculus. When you differentiate k sine f of x, it's going to be, okay, let's start with, okay, it's fine. K sine f of x, that will be k cos f of x times f prime x. That is your derivative of sine. Then the derivative of a constant is 0. The derivative of k times a to the power f of x. When you differentiate that, that will be k times a to the power f of x times ln a times f prime x. Okay, you must know this. Do not rely on the formula sheets. Okay. So now let's differentiate. Remember, this is y in terms of x here. So you're going to find dy over dx. So the derivative here, so you got your base, which is 3, the base is a, and your exponent is your function of x here, which is 5x. So therefore, the coefficient, the number in front, if it's not shown, it is a positive 1. Okay. So the derivative of 1 times 3 to the power 5x is 1 times 3 to the power 5x. You can see there's it there. Times natural log of the base. So that's ln of 3. And then at the end is always f prime x, which the formula sheet does not show you. So do not rely on the formula sheet. The derivative of 5x is 5. Now the next one, the derivative of half sine 2x. So that's your k sine f of x. The derivative there will be half cos 2x times the derivative of 2x, which is 2. And then term 3, ln of pi, you can do that on a calculator. It is a number, and the derivative of a number alone is 0. You must write down 0. Do not leave a blank space. And term 4 is similar to term 1. So that's going to be minus 5 times 2 to the power x. That's k times a to the power f of x. You can see that. Times ln of the base, which is 2, times the derivative of x, which is 1. Alright, so there's nothing too much to do here, except the 5, it doesn't matter where you write it down, you can leave it here. In between or in front, the fact is, it is multiplication, but we normally write down the constant in front, so that becomes, or you can do it like this here, 3 to the power 5x multiplied by 5 ln 3. You cannot multiply this 3 by 5 because it's not 3 alone, it's ln of 3. So you can multiply the coefficient, whatever's in front here. So it's 5 ln 3. Or you can put the 5 in front, doesn't really matter. The main thing is, you know how to differentiate it. So here, 2 times 1 over 2, 2 and 2 will cancel, you just end up with cos 2x, 0 was the derivative of your constant. Here, this is minus 5 times 2 to the power x, then 2, nothing more to do, and that is 4 marks. Let's move on to the next one. The next question here, 3.1, your word problem. You always get a word problem in N4. So, the width of a rectangular field is 5 meters less than the length. The area of the rectangular field is 300 square meters. Each side of the rectangular field is increased by 2 meters. Determine the value of the enlarged area. Okay. So, we are dealing with a rectangular field. Sketch that rectangle. Alright, so we have a rectangle. Very common shape. You always deal with a rectangle, whether it's in this section or a different section. So you should be familiar with the properties of a rectangle. Okay, not maybe you don't remember everything, but the main thing is that opposite sides here. The main thing is opposite sides of a rectangle are equal and parallel. Right, they are equal and they are also parallel. Right, so now the sides are not labeled. Let's label the sides. Okay, let's call this let's call these endpoints A, B, C, D. It's up to you on how you want to label it. I can call it P, Q, R or L, M, N, O. It's up to you. The width of a rectangular field is 5 meters less than the length. So what does that mean? Okay, so it means if the length, let's take an example, if your length is 20, then the width is going to be 5 meters less than 20. That means it's going to be the length subtract 5. Are you okay with that? So that's going to be 15. Another way to look at it is if you identify the width first. Here I identified the length first. I called the length 20, and then I said the width is 5 less than 20, so it's 20 minus 5. So now if I say the width is, let's say, 100, then the length will be 100 plus 5, because the length is 5 more than the width. You understand? Depends on what you're starting with. So there's two versions, but you're going to come to the same answer. Alright, so now that's the first part of the question. So let's say the width, this is the width. Let's call it the breadth here, because we're used to using the words length and breadth. So your breadth is, let's call it x. We do not know what the breadth is. Okay, so I'm using this one here. I'm saying the breadth, the width or the breadth is x, and the length is going to be 5 meters more. You understand that? So it's going to be x plus 5. Or you start off with x here, and then you go x minus 5. It's up to you. It's a simple thing. The area of the rectangular field is 300 square meters. Okay, so we are given the area. So the area is 300 square meters. So now, what is the formula for area of a rectangle? Okay, sorry, besides the opposite sides of a rectangle are equal and parallel, we must know the area and we must know the perimeter of all the basic shapes. So we know that area is equal to length times breadth. Your area is length times breadth. So area is equal to length times breadth. What is the area that's given to us? It is 300. Your length, I defined it as x plus 5 and your breadth is x. So we can work out from this information given to us the length and the breadth for this rectangle, which has an area of 300 square meters. So after we do that, then we can look at the second part. Each side of the rectangular field is increased by 2 meters. Okay, so let's assume that we find that the breadth is 10 and the length is 15. So then the second part of the question is, what happens when the length increases by 2? So that means 10 increased by 2 will be 10 plus 2, which is 12. 15 increased by 2, 15 plus 2 is 17, and then you can work out the new area. The main thing is to work out the current dimensions, which are the length and the breadth. So we normally, most of the time, have a quadratic when we're dealing with word problems. So you can see this is going to be a quadratic. So we got 300 is equal to x times x, which is x squared, 5 times x, which is 5x. So now you make your whole quadratic equal to 0. So all I have to do is subtract 300 on both sides. So now 0 is equal to x squared plus 5x minus 300. And now we factorize and solve for x. If it cannot be factorized, or even if it can be factorized, up to you to use the quadratic formula if you want to, or you can complete the square, which is also very important. Okay, so can this be factorized? Is it possible to factorize factors of 300? Factors of 300, 30 and 10. 30 times 10. What other factors do you know of 300? What's it? 20? I can't hear. 15 and 20. So we got 30 times 10 is 300. And then what did you say? 15 and 20. Which one will work here? Which one is going to work? Is it going to be 30 times 10 or 20 times 15? Now the whole idea is obviously the middle term. Okay, you need to get the middle term. So we got 20 and 15. Why? Because 20 minus 15 will give you 5. And a positive 20 times a negative 15, a positive times a negative will be a negative. 20 times 15 will be 300. So that is factorization. If you wanted to use a formula, it was up to you. So x1 is equal to minus 20, or the second x value x2 is equal to 15. So now your measurements are always positive. So x1 is equal to minus 20 is not applicable. Doesn't work in when we're dealing with measurements. We always measure positive. So x2 equal to 15 is the solution, is the side that we are looking for. So now, what did we say? Our breadth is equal to x2, which is equal to 15 meters. Okay. The length is equal to x2 plus 5, which will be 15 plus 5, which is 20 meters. Okay, of a rectangular field. Alright, so now if you read the second part of this problem, the second sentence there, the third sentence, sorry, each side of the rectangular field is increased by 2 meters. Okay, so the new dimensions. In order to work out the enlarged area, you need a new length and a new breadth. So your length is going to equal to, what is the current length? 20 meters increased by 2, that means plus 2 then. And then your breadth currently was 15 meters, but you increase it by 2. So now you get 22 and you have 17. What is the new area?
374.
374. So therefore the enlarged area which is 22 times 17, which is 374 square meters. So that was 5 marks. So that was your word problem. The next question, 3.2, make n the subject of the formula. So let's have a look at where is that symbol n. We need to identify its position in this problem here. So the n is the exponent here. Okay, if it's the exponent, then you need to identify the base of that exponent. So you need to identify that term and get that term alone on one side first before you can do anything else. So the term that has n is r to the power n. So the logical thing to do is try and isolate, in other words, rearrange this whole equation and get r to the power n on one side. Whether it's a left or right, it doesn't really make a difference. Right, so now, what can I do here? I want the term r to the power n alone. So what do I need to do? I need to get rid of the a over r minus 1. And then I also need to get rid of the minus 1. Those are all the things that are preventing me from accessing r to the power n. So what we can do is we can multiply by r minus 1 on both sides. So I got r to the power n minus 1 times a is equal to s multiplied by r minus 1. It's like cross multiply. Okay, you can see that. So now r to the power n minus 1 is equal to s times r minus 1 all divided by a. So because a is being multiplied there, so I divide it. Now the last thing to do here is this negative 1. So now I have my r to the power n, and 1 is separated by a negative sign. So therefore there's two terms on the left hand side. So all I will do is add 1 on both sides. R to the power n will equal to s times r minus 1 over a, and then you got your plus 1. Right, so now the whole idea was to get r to the power n alone on one side. So now what you will do is, in order to work out, or in order to access the exponent n, you need to introduce logs or ln on both sides. Why? Because if you had something like 2 to the power n is equal to, let's say, 16, then in order to work out n, I will try and make the bases equal. So this is 2 to the power n, and 16 can be written as 2 to the power 4. Here I am able to make the bases equal. So if the bases are equal, then we equate the exponents. The problem is, what happens when the bases are not equal? So if I have 2 to the power n is equal to 15, okay, then I can introduce logs or natural logs on both sides. So I'm going to go ln of 2 to the power n is equal to ln of 15. Then from my log laws, I'm going to bring down my exponent n, so that's n ln 2 is equal to ln 15. So n is equal to ln 15 all divided by ln 2. Right, so you must be able to use your log laws. Similarly, if you have log a to the base b equal to c, then a is equal to b to the power c. Same thing, if you have ln a to the base b equal to c, so a is equal to b to the power c. Whether it's ln or log, it's the same rules. The only thing is the base is different. So in this situation, here's my 2 to the power n is equal to 15. I can do this in one step, converting from exponential form to log form. Okay, so here if you compare, there's your b, which is 2, c, which is n, a, which is 15. So what do I want to do? I want to work out c. I want to make c the subject of the formula. That's converting from exponents to logs. In other words, for our example, I want n. So watch how this is now. So there's my c here, there's my n here. So n, what happens now? It's ln a to the base b. So the base in the exponential equation will become the base in your new log equation. So that's going to be ln a to the base b. You can do it in one step, but I prefer that you learn the log laws, and learn how to introduce ln, because in N5 you're going to be dealing with these examples much more complicated, where you have to introduce ln, you have to apply your log laws. So let's do it here. The bases are not the same. What is the base on the left hand side? The base on the left hand side is r. The base on the right hand side is everything here. Okay, none of these are equal to r. So what you're going to do is introduce logs or ln on both sides. Okay, so that's ln of r to the power n and ln of s times r minus 1 over a plus 1. It's a simple thing to do. If the bases are not the same, introduce ln on both sides. Try to avoid using logs, but you can use logs. There's nothing wrong with that. It's just that we prefer in calculus to use natural logs. So that's ln. All you're going to do now is bring down your exponent. So that's going to be n ln r is equal to ln of s times r minus 1 over a plus 1. And now all I have to do is divide. So therefore, n is equal to ln of everything there divided by ln of what you have here. So divided by ln r. So this is s r minus 1 over a plus 1. Right, so notice I put these two lines here. Whenever you're introducing logs, right, we're gonna put these absolute value bars. Right, so you put these two lines here. That means now whatever you have here has to be positive. Right, you cannot have log of a negative. So the absolute value converts whatever negative you have to a positive. Right. When you are substituting values, then you will understand what I'm talking about. But for now, even if you put a normal bracket, it's fine. You get full marks. But the proper way is always when you're introducing logs, put down your absolute value. So that was, you can leave it like this here, it's fine, full marks. So that is your 3 marks. If you wanted to do it in one step, well, we got another example here, 3.3, which is similar. Let's deal with it. You should be able to work out 3.3. And you must check your answer. Three point three, solve for the unknown. So it will be similar to our last few steps. Okay. So first of all, you're solving for the unknown. What is unknown here? It's only x. We're solving for x here. Right, 3 is known, this 3, 2, 2, and 12. Those are all numbers which are known. The unknown is x. So you are solving for x. You need to determine the position of x. X is part of the exponent. So therefore, I will try and make the bases equal. Obviously, this is a 12. That's a 3. It's not going to work. So what do? We convert from exponential form to log form. We introduce ln on both sides. So let me just rewrite it again. So if I have log a to the base b equal to c, a is equal to b to the power c, whether it's logs or ln. So if you want to do it in one step, you can. So there's your b to the power c here, and there's your a. So if I want to work this out, I'm going to go 3x plus 2, which is your a, okay, is equal to logs or ln of 12 to the base 3. Okay, it can be logs or it can be ln. Okay, so now, so what am I doing here? I just did the step from there to there. Can you all see that? That's in one step. Here I did it introducing ln on both sides. You could do it that way. So now take 2 to the other side. 3x is equal to ln 12 to the base 3 minus 2. You could have logs or ln, it's up to you. Okay. And then now all I have to do is divide by 3. So x is equal to ln 12 to the base 3 minus 2. These are two different terms and they all divided by 3. Hand me that calculator. Let's see what we get, and then we will check our answer. Now, okay, with ln on the calculator, see on the calculator, you can put log with a different base, but the fact is with ln, you cannot alter it. Yeah, from what I see. So therefore, let's not write it as log 12 to the base 3. Okay. So this is this log ln 12 to the base 3. Let me just show you. Ln 12 to the base 3 means you can break it up. Ln 12 divided by ln 3. Same thing. Okay, so let's write it like that. So you can work this out on the calculator. Ln 12 divided by ln 3 minus 2 all divided by 3. The problem is you cannot change the base for ln on the calculator. So we got ln 12 divided by ln 3 minus 2, and this whole thing is divided by 3. You get 0,08728650238. Let me check this answer quickly. So that's 3 to the power. What you will do is take this, substitute in place of x in your original left-hand side, press equals to. Let's see if we get 12. So 3 to the power 3x, so it's 3 to the power 3 times. This is your x value here. And then we got plus 2. Lucky, it works. We didn't make a mistake. So that is correct. So that is going to be 0,087, rounded up to 3 decimal places. Continue next time. There's another class coming in here now.